Have you ever opened a bottle of bleach and thought, whoa, that's a strong smell? Well, that smell is not just a random thing, it's information. Science begins with observation, and that sharp odor is a powerful one. It's your nose detecting active chemicals in the air. Think of it like a warning sign, not for your eyes, but for your senses. That smell is telling you to pay attention because reactive chemicals are present. Not because a chemical reaction is happening, but because the substance itself is chemically active and capable of reacting under the right conditions. That distinct odor comes from tiny chemical particles leaving the bleach solution and entering the air. These particles, called molecules, are far too small to see, but they travel from the bottle into your nostrils and interact with specialized sensors inside your nose. Those sensors send signals to your brain, and your brain recognizes the pattern and says, "That's bleach." So, what exactly is in that bottle of household bleach? Well, it is mostly water, H2O, the largest ingredient. But dissolved in that water is the active chemical that makes bleach work, sodium hypochlorite. Sodium hypochlorite is the real star of the show. It's a chlorine-based compound that reacts with other molecules through a process called oxidation. That's what makes it so effective at disinfecting surfaces and removing stains. Inside the bottle, sodium hypochlorite exists dissolved in water in a relatively stable chemical balance. But it isn't chemically inert. In water, some of it can convert into other chlorine-containing compounds. One of the most important is hypochlorous acid. These chlorine-based compounds are highly reactive. They interact with bacteria and viruses in ways that damage essential proteins and structures, killing the organisms. The same reactivity also breaks apart the molecules that give stains their color. It's not free chlorine atoms doing this work, but chlorine-containing molecules that are chemically eager to react. And that reactivity is what gives bleach its power. Now let's talk about why the smell of bleach can sometimes become much stronger. One major factor is heat. When bleach is stored in a warm place, like a sunny area or a hot garage, the molecules in the solution move more rapidly. That added energy makes it easier for reactive chlorine-containing compounds to break down and release volatile byproducts into the air. As a result, warm bleach smells stronger than cold bleach, even if it's the same product. Light, especially sunlight, has a similar effect. Exposure to light speeds up the chemical breakdown of sodium hypochlorite. This doesn't make bleach more powerful. It actually causes it to degrade, but it can increase the release of chlorine-related odors. Another reason the smell intensifies is when bleach reacts with organic material. Oils from skin, food residues, mold, and bacteria all contain compounds that bleach is designed to react with. When these reactions happen, new chlorine-containing substances can form, including compounds called chloramines. These are not the original bleach itself, but reaction byproducts. Chloramines are often more volatile and have a much sharper, more irritating smell than bleach alone. That stronger odor is a signal that chemical reactions are actively occurring, and it's also why bleach should never be mixed with other cleaning products. A very important point to understand is that a stronger bleach smell does not mean better cleaning. While the odor tells you that reactive chlorine-containing compounds are present in the air, the actual disinfecting power of bleach comes from the liquid reacting directly on surfaces. Stain removal works the same way. The chemistry that matters happens where the bleach touches the floor, the countertop, or the surface being cleaned, not in the air and not in your nose. When a room fills with a strong bleach odor, it means that chlorine-related compounds have moved into the air, where they are no longer doing useful cleaning work. Because our noses are extremely sensitive to chlorine compounds, that smell acts as an effective safety warning. It can irritate your nose, it can irritate your throat, it can irritate your eyes. That irritation is your body telling you to get fresh air. If the smell of bleach becomes overwhelming, it's a clear sign that you need better ventilation. Open a window. Turn on an exhaust fan. Clearing these airborne compounds from your breathing space helps keep you safe while allowing bleach to do its job where it belongs. On the surface, you're cleaning. Using more bleach than you need will not make things cleaner. It will only increase the amount of reactive chlorine-containing compounds released into the air, where they are no longer doing useful cleaning work. One of the most critical safety rules is to never, ever mix bleach with other cleaning products. Mixing bleach with ammonia-based cleaners, including some glass cleaners, produces toxic gases known as chloramines. Mixing bleach with acidic cleaners, such as some toilet bowl cleaners, can release chlorine gas, which is extremely dangerous to breathe. These gases can cause severe irritation and serious damage to the respiratory system. Always read product labels. Stick to one cleaner at a time. While these chemical reactions are well understood by chemists, they become hazardous very quickly in household environments. In conclusion, the powerful smell of bleach is a fascinating piece of chemistry you can observe every day. It comes from chlorine-containing compounds leaving the liquid and entering the air. That smell is a useful signal that bleach is chemically active, and an important warning to handle it with care. Use bleach in well-ventilated areas. Do not use more than you need. Never mix it with other cleaners. By understanding the science behind the smell, you can use this common household product safely and effectively. Science is all around us, even in the smell of clean.